Hi, my name is Rhee, and I'm going to tell you a little bit about our laboratory. You're interested in understanding how blood vessels change during hypertension and related diseases. So chronic hypertension or high blood pressure is a deadly condition that affects more than 70 million Americans and over 1 billion people worldwide. It is the leading cause of chronic kidney failure, as well as a major risk factor for heart failure, stroke, and other serious cardiovascular events. What makes it more deadly is that there are no significant symptoms in the early stages of the disease, so it's sometimes referred to as the silent killer. The blood pressure is determined by how much blood the heart pumps out against the network of blood vessels in your body. In most cases of human hypertension, the heart output may be normal, but the blood vessels are abnormally constricted, providing high resistance. So this can be a chicken and egg problem where the abnormal constriction can be the cause of hypertension, or it can be a result of the hypertension. Our laboratory and others have reported several molecular changes in blood vessels that occur during hypertension. In particular, we are interested in a protein called potassium ion channel found at the surface of smooth muscle cells in blood vessel. These channels allow potassium ions to flow out of the cell, which relaxes the cell, and eventually it dilates the artery. So as you can imagine, if these potassium channels are lost during hypertension, what would happen is that the arteries or the blood vessels will be more constricted. However, we still don't fully understand how these changes occur or how these changes affect other proteins in the blood vessel. But recently, we have identified so-called scaffolding proteins in smooth muscle cells that can interact with the potassium channels that we're interested in. The scaffolding proteins were originally described in neurons in the brain, where they act as scaffolding centers to recruit multiple proteins that act as a protein complex. We expect that these scaffolding proteins we found in smooth muscle cells to mediate the formation of multi-protein complex that can affect the diameter of blood vessels. By understanding these mechanisms better, we hope to design therapies to treat blood vessel abnormalities in hypertension and other diseases. We use conventional methods like biochemical protein assays, real-time PCR, as well as functional assays where we take out the blood vessels and look at their function. At the same time, we're still developing state-of-the-art imaging techniques to look at these small molecules in the blood vessel. We're actively recruiting more members to the laboratory. If you're interested in graduate or postdoctoral study opportunities, please don't hesitate to contact me.